Okay, here is the meter I'm working on. It's not finished yet because I'm thinking about adding some more stuff into it. The stuff that's in orange, that's what's going to be added onto it later on. And stuff in blue is what we have already. We got here is the voltage and amp connector right there. The voltage and amps measurement connector right there. It could be either both, depending on the switcher. This switcher turned on, it's measuring current. If it's not on, it's measuring voltage. This here is optional. This here I haven't put in there yet because I am gonna wait till I get a good diode. Because why put a resistor in there if you don't need it yet? A 10 kilo ohm resistor. You'll need it in order for this diode here not to short it out to the diode. You can't go too high on resistance, so the reverse resistance would be 10K, which is perfectly fine. You don't want to go too high, otherwise you'll have some voltage loss on your meter because of this 470K resistor right there. If you have it less than 470K, you won't have very much voltage loss. This loss is caused by when it makes like a voltage divider. When you make a voltage divider, it'll divide the voltage out and it'll go less. And it may look like hardly nothing there when you might have some stuff voltage there. That's why we must put at least 10K, so we'll have like 10K reverse impedance and 470 kilo ohms of forward impedance. This here will also convert to direct current too. You might need to add a capacitor in it. I might add a capacitor. But I'm not sure yet. Anyway, what's this here? This is our plus ohms jack. It has a variable resistor going from positive VCC to the positive ohm jack. Then you put minus VCC, and it goes through it, and it connects the meter directly onto it. It doesn't need this voltage follower for that because it's not measuring voltage; it's measuring current for that. It's better to measure current instead of the voltage or the resistance. Now, on this one here, this is a 10 milliamp meter, and this is since the resistance of it is bound like 200 ohms at least. You don't need a resistor for it to limit it to 1 volt. It has 1 volt range. In fact, it doesn't even go to 1 volt range. It goes to 2 volt range. So this is actually, when I erase this here, put 2 volts. 2 volts right there. I'll waste it and put the other one so you don't get confused thinking that's something added on. 2 volts. Range right there. The whole idea of using this voltage follower on this as op-amp as a voltage follower is to make it so that it can replicate the voltage without using too much of a load on it or using up too much current. If you do it through a voltage divider, stuff like that will lose current, and then it'll when it lose voltage because it'll drop by how much resistance, how much the bottom resistor here is by. And since we can't have it floating, that's why I put the 470 kilo ohm resistor in. You can't have it floating. Otherwise, you'll get a measurement on the meter when there's nothing hooked to it. This here is a shunt resistor. I used 17 inches of composite video cord. a cord for a composite video, like plug into DVD players, into TV and stuff like that. Use the cord off of it. Then when I make that RF modulator, use the rest of the cord from it. Use 17 inches off of it, since just one pair. One RCA jack is equal to 4 ohms. Why? I have no idea. Why would it be 4 ohms? That seems kind of high for a cord. And how I figured out how to lower it down to a reasonable range is I had to take a third of it off there. It was like 52 inches on that cord. And at 52 inches, I got like 4 ohms. So I decided to take a third of it off there. Once I took the third of it off of it, it gave me 1 point something ohms. It's not to deal with it. I could have probably went lower. But yeah. This switch here is a single pole dual switch. We're using a 3-way light switch to do this. With the 3-way light switch, I'll switch between. In fact, with this one here, you don't need a 3-way light switch. You can just redraw it, put this resistor here between here and here, and then when this turns on, it's 2 volts. When it's off, it can be 10 volts range. But since I already bought that, I'm gonna leave it that on the schematic like that. I didn't know until I had to take the resistor out and put a wire in. You probably want to see it now. Let's go take a look at it. Okay, here it is. This is 10 milliamp meter. I had a 1 milliamp meter, but I don't know what happened to it. What happened is that this needle here stopped going full scale when it's supposed to go to full scale. Stuff like that. I don't know why. It moves, the needle moves, it just doesn't go very high, very far like it should to represent the current. So I decided, since I have a whole bunch of these meters, I'll just take another one. So I decided to take this 10 milliamp meter here. Here you see right there, 10 milliamps. It has a resistor here. I don't know what big size resistor this is. This is a variable resistor. I don't know what size it is, but it was good enough for this. Had them left over for something. This light switch here, it turns the volt and amp meter on. The resistance meter is always on because it doesn't matter if it's on or off. It will be on as long as you have no current flowing to it. It's off. But when current starts flowing to the resistor, it will be on. Resistor under test. Then you have right here, this is our amp and volts selection switch, which currently it's on volts. This switch here, this is our range switch. It's from 2 to between 1 volt, 2 volts and 10 volts. And decided to use 3 9-volt batteries so that my resistance meter can have a better handling high resistance values. If you use just 18 volts on it, it might not go very high on resistance. Still doesn't go very high on 27. It would have been higher if this meter had less current on full scale. Anyway, you probably want to see what it does. Okay, let's turn it on. Okay, it's on. I'll take my. Oops. Hang on. Alright, we have it set to 6.3 volts. Right there, we're getting on around 6.3. 5 a little bit. It's a little bit off. Just because the resistors are not exact value. There's some tolerance issues in it that cause it to be inaccurate. And there's current on here too. I can switch over to current by turning this knob on. Good. 3.68, and there's actually no, it's 6.3 on the volt. So right there is 3 amps is 6.3. That'd be 3 amps with the, turn it down a little bit. Set it to 1 amp. 1.7 ohms is what that's in there. So I'll just switch over the range to the other range. And we should get, well, there's 1.6. This is 2 volt range. So it's about half, which it is, shown there. Okay. I'll switch back over the voltage and switch the volt setting to regular volt range of 10 volts. Right there. I get it adjusted, tune it up, tune it to nine volts. Showing up on there is 8 on there. So it's okay. It's accurate is gonna want to get it at least. What the resistors are doing that I showed in the circuit, they're eliminating the current. They're eliminating the current so that when voltage is costed, its current will be linear to the voltage. And that's how it basically works. Of course, if you put the resistor just directly on it, not buffer it, what happens is your voltage source might limit the voltage limits the current too much, and the voltage reading on that will be wrong. That's the whole idea of using a op amp like this, is to buffer the voltage, is to equate the voltage with better current on it, better the current where it's not limited too much. The impedance of the forward impedance would be 470 kiloohms, and reverse would be, when I get that diode put in there, would be like 10K. Even though 10K is kind of low impedance, it's just not to do because you can't put any big resistor on it, otherwise your voltage will be messed up. Well, that's it for now. So I hope you enjoyed this video. So thanks for watching. Hope you like it. I'll show you the ohms before I leave. The ohms will just shut this off. Like that. Just take these two here and touch them together. Of course, it's not tuned up all the way, as I can see on there. The resistor ain't. So let's put a resistor in there. Let's put in there. No, not that. We put in there first a 1K resistor. If I can find one. That's 10K. 1.5 good enough. With this resistor across here. See if I get the thing on the screen. I'm probably not going to be able to get it on the screen. So I have to put the camera down. Twist these wires around, twist these leads around the wires. Okay, oops. Okay, then I'm gonna adjust it till we get 1, until we get to 10. It seems to be going down. We'll turn this, so it goes up. Round there goes our 10. Okay, now if I take another resistor, that's in the that's higher than 1K. But it's a little bit bigger than it, like 3.3K. It should go back. It should go back 3 times less. It should be divided. It should go down by subtracted by 3.3. So I'll attach this to here. Okay. I got it on there now. And as you can see, the 3.3K is at 6. 8, 7. It was supposed to be 7, but it's alright. It's reasonable. There's probably resistance in that meter, like I said, it's like 200 ohms of resistance. So it's about around that range. So there you go. I hope you enjoyed this video. Thanks for watching. Hope you like it.